George!
George, you knew I was going to say it.
I
Don't
think
act
she-
surprised.
Alright, first Steven.
We're going to say it.
Thank you. A cross section has a width of long story short, 16 over 15 pi. If you did decimals, too bad, you just gotta check it.
Wait, what?
16 over 15 pi, or 1 point something.
Not even close.
Oh. Not even close? Check your formula.
I got 8 pi.
I don't know.
Did everybody else get 16 over 15 pi?
Yep.
No.
Check your formula.
Formula.
Oh, maybe because you forgot to cut in half. I bet that was it.
Would that make it?
Because it was pi r squared, and top minus bottom is the diameter. So you have to cut the top minus bottom in half.
So I put the half on the outside or?
Put a fourth on the outside. See what I mean? Because it'll be w squared over 4. So you have to pull a 1/4 out.
My formula looks like completely different, but I got the same answer.
Oh, what did you do?
I have x squared minus parentheses 2 minus x squared over 2 squared. No, it is the same. There's a square on the outside. Okay, never mind.
Yeah, we got to cut.
It's just simplified.
Yeah.
Yeah. Do you forget to
I
cut
didn't
in
see the
half?
square on mine.
Yeah. Number next one.
12.
128 pi over 7. Remember, they did it by hand. You guys are doing calculator, and that's okay. Just check the decimal. So that'd be 118 point something.
Hold on.
Pi.
128. Divided by 7. 57.446.
Oh, with pi or without pi?
With pi.
Hmm.
I have 2 more even.
Meant without pi. What else?
It's going to be 68 and then 70. Right?
Yeah. 68.
33. Oh, they used their calculator. E.
Can I get extra?
361.9.
Yeah, 70 I didn't know.
Oh, 70 I got.
Oh no, what happened? Is that our multiple choicey ones?
Okay.
Did you get it?
Okay, let me be sure. And then I had a question on number 9 because my calculator, I was plugging into my calculator, but I got it wrong.
Okay. So we want to look at 9. We want to look at the ones at the end, the 70-ish multiple choicey ones, right? Anything else we want to look at?
Yeah, number 9.
Oh, were there any more evens? Did we get them both?
That was all.
Oh, 68 and 70. Amanda, do you have anything else? Okay. So 9, 35, and then the multiple choicey ones at the end.
I can do 35.
I got A and B, but not C.
I figured we'll peek at the questions really quickly and make sure the setup is good, and then if you need to see the working out, then we'll get people to the boards. Go team. Dun, 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 dun. Nice. Dun, 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 dun. How about now? There we go.
Too bad he's your
All right, number 9. What were the directions? Because it's coming. First of all, page number for homework. 414. Do you guys feel accomplished? We're in chapter 8.
No.
Yeah,
Because everyone else is in chapter
3,
5,
But our
5,
chapters are longer.
4.
I mean, their chapters are longer.
but still.
Just don't think about it. Okay, so
If they cut theirs in half, right?
True.
Double.
Yeah, we're almost done with the book.
We really are though.
But next semester's all new stuff.
yeah, chapter 9 we're
Sequences,
slowing.
series,
Chapter 9 we're
Power
slowing.
series,
9 and 10 we're
Halloween.
slowing.
secret.
414, right?
Yes.
Okay, number 9. What were the directions?
Oh, find
Oh,
the volume of the solid generated by revolution.
Okay. Was it a disc or was it a washer?
It was a disc.
What number are we on? 9?
Number 9.
What was it? Disc?
Why?
I did a
Where are you revolving about?
Oh no, I did.
And it's flush. If it was about the X, it would definitely be a washer, right?
Yeah, I did write myself. I just still did.
Okay. So set up dx or dy?
dy.
Mm-hmm. So everything needs to be in terms of y, which, oh wait, it already is, right?
Mm-hmm.
Yeah.
So we need y bounds. So we're going to have our v equals, because we're going a this away. We're going to have a thickness of a this away, and so it's going to be a this away. Okay. Because we're perpendicular. We're going to pull out the pi. It's flush, so we just need a big old r, and then square it, and then do dy. Our bounds are going to be 0 to 1. And our right is going to be tangent of pi over 4y minus half.
But is that wrong in my
But you can use x's
Mhm.
in your
Maybe not.
calculator.
No, I don't.
I don't know. Are you in radian mode? Did someone borrow your calculator and change it to degree? That would make a big difference.
That would kill me. That might actually cry.
You know, I just realized that I have
No,
not
I'm in radian.
degree
Oh.
all year.
Did you put a big old parenthesis with squared? That might have messed you up.
Because it might have been the pi over 4y squared, but not the 2 squared. Maybe.
Yeah, like it's easy to put that
Oh,
square in the wrong
yeah,
spot.
I fixed that too.
Oh, okay.
Because I thought the same thing. And then,
And depending on the integral, maybe you have to like have that extra be like that. I don't know. And the pi over 4 you didn't just write, right? You wrote in parentheses for tangent.
I did it with the like n over d thing.
Oh, yeah. And y was on top, not bottom.
I put it on the outside. Not on the outside, but like next to it. Should I put it on top?
You're... What was the correct answer? That pi?
I don't know.
Who has the right one for 9?
I have the decimal,
What's the decimal?
0.8584.
With pi or without pi?
With pi.
Ooh, times pi.
I don't know what I did wrong.
Something was funny. 35, right? That's our next one? And then the multiple choicey one. 35, was it a particular part or just like the whole shebang? Okay. Oh, some of you guys asked me this one yesterday. Okay.
I actually used it at lunch.
Yeah, that's yesterday. Okay, so
Oh, sorry.
it's okay. We are taking this defined like that, revolving it about the x-axis. Now, if we were revolving it about the x-axis and it was discs or washers, wouldn't we have to have dx? If we were revolving this about the x-axis and we were using discs or washers, wouldn't we have to use dx? Why don't we want to use dx?
Yeah.
So, good thing we're using shells instead. Shells, we're going to have a parallel, representative rectangle, right, or slice. So revolving for letter A around the x-axis, what did you guys, that's not very even, but that's okay. We kind of keep track.
Yeah.
Ish, what would that be? Ish?
Yeah.
Radius comes from the axis out. So that's going to be my R. And then height. Anyway, and then height is going to be the length. So let's have it meeting right here at some x, y. What did you guys put as radius for A? It's the y value because it's the height of the point. And then what would the height be for my formula, RH?
12
Yeah, the function, because it would be the function minus 0. So R is y minus 0, function minus 0 is height. For letter B, now we're revolving about what?
Juan. Y equals
Does that
1.
make sense for A now? Yeah. Okay. And then for B, we just gotta change our orientation to be y equals 1. We're still going parallel to, so we just use some little perpendicular. And we're revolving him. You don't have to have the picture perfect, but I feel like some sort of representation helps you at least figure out, visualize the radius. The height will still be function minus 0, but what's the radius now?
1 minus
Top minus, what would the
Y.
bottom be?
the function.
The y. Because it's in terms of y. So I can say 1 minus just y, because it's missing. It's missing whatever that y component is. So r would be 1 minus y instead. And the bounds would be the same, yeah? Still from 0 to 1. So you can kind of use that to generalize, because as soon as we go to y equals 8 over 5, isn't that also going to be up here? because that's 1 3/5, so it'll be a little bit higher. But you're going to have the exact same idea because you're still going to have the function minus 0 being the height of your cylinder. But now what's the radius going to be if you're going up to 8/5?
8, 5, 1,
8/5 minus 1. So for this one, r will equal 8/5 minus y. This one, r equals 1 minus y. What's r going to equal for this one if my axis is down here at negative 2/5?
Y plus 2/5.
You can say y plus 2/5, or you could say y minus 2/5. Oh, sorry, minus negative 2/5. Same thing. So just think when you're doing radius, you need to kind of visualize in order to be able to do top bottom. So let me show that last one really quickly. Oops. I just erased all the others. Sorry. Negative 2/5 going around. They were represented at some sort of point. If I'm revolving. The height is the same thing, function minus, but the radius now will be the top is the y value of my point, and the bottom wouldn't be 0, the bottom would be negative 2/5. So y minus negative 2/5 or y plus 2/5. So it takes some time to be able to visualize with shells because we're not used to it, but how many of you guys are at least somewhat visualizing the picture or drawing some sort of picture in order to think through? Okay. I don't know. It helps me, but I know that's not how everyone thinks through things. So, and then we want to peek at the multiple choice. Then we're done.
Just
Multiple.
70.
Just 70. Any other ones?
Yeah,
Anybody else?
68.
68 and 70. Okay. So then,
Did you try going to projector view? It'd be easier to move around.
projector view in the ebook.
Yeah.
I'm not so sure if that's easier because I like being able to. This is actually harder. How do you have that? This one? Because I can go back and forth easily from the pages on this one.
What is it?
Projector like cuts out all the extra yada 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 to make it prettier.
Always prettier.
Then we're good? Yeah. Okay, so on number 68, you guys talk it out because some of you got it. What'd you do?
I drew a picture.
What's it look like?
It looks like a exponential function. The y-intercept is 8. 8 is not like that.
Exponential.
Oh yeah, a negative face concave down. And then the x-intercept is at 4.
So downwards problem.
And they're asking,
X-axis and a y-axis.
yeah.
Not a bad thing, I just thought it was funny. Okay, which of the following is the best approximation of the volume when it's revolved about the x-axis? Oh. And this says first quadrant, so we cut them. Where was this intercept?
4, 0. You had to figure it.
Right, so the y equals 0. That's equal to 0 solve. Disk, right? Because it's flush. And so I can go ahead and just make it dx, right? Thicknesses. Top minus bottom will be my radius. Find the balance with your intercept, so we know it's from 0 to 4 since we're doing dx. It's not a washer, it's a disk. Top minus bottom would just be the function. Does that make sense, bud?
Yeah.
And then on number 70. Ooh.
I know. I tried
That's a little fun. So we have e to the negative x, that's a horizontal flip, right?
Yeah.
So we have, it's going through 1, 0. Sorry, 0, 1. So we have that one, and then we have that one. Alright. So it would be going this way.
Yeah.
And x equals 1.
Oh, that's what I did wrong.
Because you have to make the boundaries what they say. So either negative x, either positive x, x equals 1. It's being revolved about the x-axis, so we have washers, yeah?
How did you know it was? I drew my.
Hmm?
How did you know that? How did you know that it was about that's the shaded area? Like, why wasn't it?
Okay, hold on. Remember we talked through this one? When they give you enclosed by, you have to make sure those graphs and those graphs below them are boundaries. So, check it. If I have e to the negative x, e to the positive x, and x equals 1, this is the only enclosed region by those three functions. Does that make sense? Yep. So then we just have our big R, right? Little r. Big R is just e to the positive x minus 0. Little r is e to the negative x minus 0. Which when you square it, e to the 2x minus e to the negative 2x? That's awkward. Oh. No, that's right. Big R squared minus little r squared. That looks funny when I wrote it.
But are you squaring the x? Would it be e to the x to the square? So I thought it was e.
What do you mean?
How does it become e to the 2x?
Because of how much of a power you multiply. And this is my big R. So the whole e to the x minus 0 squared.
But it wouldn't be e to the x to the square.
Well,
So that's what I was thinking.
it is e to the x squared, which would become e to the 2x.
But you know how there's like, how can you do this?
It's dx.
Oh, thank you. I was ready to tell. Oh,
How it's like that sometimes. It's not that.
because power to power you multiply. Think of it this way. If you had e to the x squared, like bases you add that. Is that cool? Alright. With that, kiddos, here we go. Notes open. 8-4. Arc length and surfaces of revolution. While you guys write, I'm going to go ahead and go title. Go title our endeavor cards. Arc length will come first. In our section, I think surfaces will come first, technically, because I think they will come first, because they're the end of section 8.3 that we skipped. And then come arc length.
Did we do 8-3 in parts, or we just did it all together on separate days?
We did 8.3 discs, washers, shells, separate days, but it was one part, one homework.
Okay.
However, 8.3, the very end, surfaces, I thought it belonged better with arc length, so it's kind of separated. So like the homework for 8.4 is going to have a few problems from 8.3. Does that make sense?
Yep.
Okay. Perfect. Especially if we're thinking like over a certain interval, what if we had like a vertical asymptote? Wouldn't that be an infinite arc length? To some extent, if you think about it. So rectifiable basically is just like, oh hey, it's natural arc length that we can find because it's finite. It's going to be a constant. Or it's going to have a set value. And how do we know f prime has to be continuous? F is rectifiable. We're not going to make this an endeavor card because this isn't a definition that I've ever seen them make you use, but it's good for homework for you to be able to know like, oh hey, does this actually have a set arc length for me to find? What causes a dilemma with arc length? Yeah, if it was a straight line, make it a little bit more curved. If it was a straight line, how would we find the distance between 2 points?
Just Euler.
I just gave the answer. How would we find if it was a straight line? The length between 2 points of the function.
Or like you do have to be like
Ooh, not over b minus a though. We would use f of b, f of a. We would want to use the distance formula, yeah?
Yeah.
So we would have the point b, f of b, yeah. And then we would have a, f of a. And we would use the distance formula. If it was linear, D equals the square root of, what do you guys start with, x's or y's? Doesn't really matter.
I like X's.
X's first. So we would have b minus a squared plus f of b minus f of a squared. Problem is though, does that work if it's curved? No. However, let's think through what we know. In order to make this a better and better and better approximation and approach the actual length, don't worry about making it go through the integral, because the integral will help it accumulate all the way through. What do we need to do in order to eliminate this error that we see?
Take the limit.
Take the limit, but what do we want to happen?
We want to accumulate.
We want to that's true, we want to accumulate through, but we need to make it perfect. We need to make them infinitely close. We need to have these 2 points approach each other to get these little arc lengths infinitely close, and then we can go ahead and accumulate them throughout. Well, how do we get them infinitely close? Now, we started with a linear function. I showed you a curve function just to let you know, hey, there is error. But if we can get these, we still want it over this interval. This would be a good approximation. Well, kind of good. But if we can cut it in half and do 2, right? If we can cut it in fourths and do 4, if we can cut it in eighths and do 8, etc., etc., it'd be a better and better and better approximation. That kind of reminds us of rectangles back in the day with area under the curve, right? So, let's see how this formula seems to work. Wait a minute, but I don't see my b and a and f of b and f of a. What are they using? The derivative?
Nice.
Well, hold on, Amanda, you just said a second ago, what is the derivative? Slope? The slope, right? And how is the slope found? The rise over the run, right? And if we're trying to make these infinitesimally close, then couldn't we think about the f prime, which would give us, in essence, the tangent line. So if we were dealing with, instead of actual 2 set points, if we're dealing with a tangent line instead, and if we're trying to find the distance of a tangent line, let's have A here and B here. Couldn't we, in essence, there we go. Couldn't we find the distances of the tangent line, which is linear and it is related to our curve? It's just not the secant line necessarily. And couldn't we then go ahead and think, okay, if I have my f prime, it's in essence kind of like dividing everything by b minus a. And saying, okay, we're not actually going a width, we'll have the integral go that width for us. We'll have that integral give length to these little segments. So we don't want the b minus a, so we can go ahead and, in a sense, kind of factor it out. And then we would have just 1 squared, then we would have f of b minus f of a over b minus a squared, but for the tangent line, that would be the derivative, it wouldn't be the actual function. Or you can think, if I'm making them infinitesimally close, that would be the derivative. They kind of correlate that way. Anyway, I didn't want to necessarily go through a proof, and I didn't necessarily go through any sort of proof as to why this formula is entirely correct. However, I'm trying just to attach in your mind some sort of reason as to why the arc length formulas, whether you're going in terms of a function f of x or in terms of a function g of y, dx or dy, we can do it either way. It's not going to make a difference. There is no magical which one is right, like cylindrical shells or like discs and washers where you have to correspond. You can do it in either form. You can put it in terms of x or put it in terms of y, because either way we're moving along the curve. So you can think of this as basically a simple Pythagorean theorem that stands for a distance. And we're using the derivative as our means of basically thinking along or thinking of a length of a line. The lines are getting infinitesimally small and then they're accumulating throughout the A to B. So, endeavor number 8, is it 8? Let's go peek at an example. Do you guys see the Pythagorean though? It's really just the right triangle, we're just finding the hypotenuse. Is that okay? Okay. So then,
I don't understand the difference between the two.
oh, it's literally which one's going to be easier. So look at the examples. If we have it in terms of y, sweet, we can do it in terms of y. If we have it in terms of x. Well, it is going to be dy. Sorry.
No, but I was going to be dy, is it?
In terms of y. That's it.
So you just write one of them down.
And then say it's okay to do it for y's too? Yeah.
Can you just write F instead of G?
So question, if I want that length, what do I do?
You.
I say it's in terms of x, so I want dx. That's literally all it is. You just pick which one you like. And yeah, we're not solving now. 1 to 2, because that's my interval I want the arc length over, right? Square root of 1 plus, what do we have to do to find?
It's going to be
Yeah.
x squared over 2. I'm doing
I beat you?
Yeah.
Bring down the 3, simplify, make it a 2, and then bring down the negative 1. What? Oh, because it's 1/2 x to the negative 1 power. Right? And then make it a negative 2. So then we
The
go
whole
ahead.
thing goes in there?
Yeah.
Ugh, this is bullshit.
Is that good though?
To make that U?
That'll give us our
Is
place.
this a calculator problem?
I would say.
Yeah.
Cool.
I mean, I don't want you guys to get totally rusty at being able to do things by hand, but if you're okay with getting set up and doing calculator and just not forgetting how to do things by hand, then we're okay. You want to do every other, but this one, there's not really a U prime. You would have to probably FOIL, get common denominators, see if something simplifies, it would be a mess.
But in like the whatchamacallit, I'm not AP
They shouldn't give you one that type. So if they're doing like an arc length, they're just expecting, like, they just want you to know the formula pretty much. They probably are a calculator one. They would have just a plain old integral be one where they want you to use your skills. So what are we going to do on the next one? Wait, do we have to worry about crazy stuff like intersections or like orientation or top or bottom or any of that?
No. Orientation.
Well, orientation, yeah, if we're thinking about this. I was thinking like if one was on top and then the other was on, there's only one curve that we're dealing with, so we don't have to worry about all the problems that come in when we're dealing with two curves for area between. So in this one, we just say, hey, look, I see y, so let's make it. And I can use my bounds of 0 to 4, no big deal, and I can use my formula of 1 plus somebody squared. Uh-oh, what do I do? Oh, this is a struggle, except the formula just said take the derivative in terms of y. Fine, that's fine.
This DDY.
So bring down 3 halves and I get 1 half. What do you keep writing?
Why do you keep writing B?
Oh.
Oh.
What should I be writing?
S, right?
S.
Little s.
Arc length.
Is it the less in the formula?
Yeah.
I didn't even
I
know.
might do SA for surface area when we get there. Is that okay?
Yeah.
S is pretty common for arc length. Even in pre-cal, we used S for arc length. But, because A is for area, but then big S is surface area. I don't know. We'll figure out something. Sorry, 3 halves come down, 1 half. We have our 2y, right? Our u prime, and then we have our y squared plus 2 to the 1 half.
I just realized.
Oh, that's true. That's what I use. Oh.
Miss D, why, can you remind me why we're not, I'm sorry, but why we're not doing, why we don't have a do RDX?
Oh, why it's not a problem. Because our formula, this is why maybe it's important to think about the orientation, because it says, hey, if you have this, sweet, just take the part.
Oh, okay, I didn't read that part. Yeah.
Yeah, so it frees us up to be like, we're not having to take a derivative in terms of, we just need a derivative. Because whether you're looking at dy dx or dx dy, it's going to be used the same way for the Pythagorean arc length formula. Sorry, let's go back. There we go. So we throw them in and then he all that we would need to solve, right? If we did want to solve them by hand, we have y squared times y squared plus 2, which would be y to the 4th plus 2y squared plus 1. Ooh, which would factor. So this one you could do by hand.
Yeah, the 1/2.
There we go.
Wait, was that?
Because since there's no plus, I can just say it's this times itself, so the y will be squared, and then the 1/2 will go to be a 1. And then I brought the y squared to be y to the 4th, y squared into
Well, how'd you get rid of the 1/2 power?
Oh, because it's squared. We'll cancel.
Oh, because it's not a plus. Right?
Yeah, it's not a plus. And then I can go ahead and make this, isn't this just y squared plus 1 squared? Right?
What happens?
So it's just y squared is 1.
So this one could be by hand. But there are definitely going to be ones that's like, no, you wouldn't be expected. But this one you could. Just thought I'd point it out. Technically it'd be an absolute value, but since y squared plus 1 can't be 0, yeah, it's not going to be a problem. It's always positive anyway. Ooh. And observe that you can't solve it yet. Well, that doesn't sound fun.
Observe that you can't solve it yet.
I have different integral.
That's
It's
awesome.
interesting. Okay, we're going between 0 and pi. We know what sine looks like, right, cool kids?
But don't know. Yeah.
We need 0 forever. Uh-oh. 0 and pi, what do we got?
Yeah.
Okay, we want the arc length.
So
Alright, no big deal.
the integral from 0
Little
to
s
pi
equals good.
of square root of 1 plus cosine squared. Cosine of x squared.
Why don't we just solve?
What's wrong with this picture?
1 plus cosine squared of x is sine squared of x. Yes? No?
1 minus cosine squared of x is sine squared of x. So then what would you do?
We could use
Oh, wait,
cosine
you
is 1 over
integrate?
cosecant.
There's something called trigonometric substitution that we would be able to use to solve it, but we have not learned it. I have not seen it in the AP test. However, that's what you would have to use. And basically, trigonometric substitution is this thing that allows you to deal with square roots of functions that you can't solve any other way in an integral. But anyway, observe that we can't solve it yet. Yeah, we can't solve it yet. Okay, check. And then just plug it in your calculator. Yay! Anyway, that was kind of lame.
How is that a calculator can do stuff we can't even do by hand?
Because
No,
it's
we
using
can't.
approximation techniques and it's able to do those approximations much more quickly than we can. We could approximate, right? We could make trapezoids or rectangles and we can make them infinitesimally thin. You guys haven't learned Taylor and McLaurin polynomials to help you approximate
I
that,
might
right?
have one time.
Someday. Soon and very soon, but far enough that we still get Christmas break. Okay! Number next one. Surfaces of revolution. Surface. You've always seen surface whenever you've seen surface area.
Bum bum
Bum,
bum.
bum, bum. Bum, bum, bum. All right. You guys are weird. So, what I want you guys to think with this are bands.
Is today Wednesday or Thursday?
Wednesday.
Wednesday. See, okay. Otherwise, I wouldn't know. Crazy Wednesday, though.
The churros.
Yeah.
The dang churros.
There's churros today?
At lunch.
At lunch, in the gym, during ELF. I can figure out how to make it really fast during this period. Okay, so,
Wait, how long is the cake? Just put it together, right?
there's a lot of stinking churros. But at least up there, if there's a double oven, and so I can put in like 1, 2, 3, 4 different racks at a time. If it was a single oven. Okay. And Mr. Gavin has the thing closed so he can sneak in and skip up your shop.
Is there an oven in the teacher's lounge?
Do
You
it.
microwave it?
Okay. Yeah, so that's not gonna help.
Oh, okay.
Good idea though, but
This one has 2.
I need you to think of bands.
Like heavy rock or like
Nope.
soft rock?
Like a wedding band.
Ha! Got me.
Athletic people will be like, ooh, like that. So,
What are you trying to say?
long story short, if we're trying to do surface area, okay? This thing that you're looking at is called a frustum.
Say that again.
Frustum.
Yes, I'm very frustrated.
Oh, is my bell not working? Is it time to go? Ah, you're killing me.
Beelzebub! George, why did you
Because Beelzebub is Stephen King.
And?
You don't know
However,
seven?
not everything that we see as negative, and we can't blame it all on Satan when the Lord uses hard things. We change. Okay, so
Beelzebub.
Just listen to
Let us
little
run it,
preschoolers.
person.
That's
No,
the
middle
thing.
schooler.
Yeah.
They were kind of small.
Joyce, if you like this video, leave a like, subscribe, and a comment in the description below.
Anyway, thanks. Pause it.